Alright everyone, so in this video we're going to be discussing isotopes and ions. So in the previous video we were talking about atoms and protons and neutrons and electrons and how each of those can be calculated using your periodic table. So if we look at this first part, okay, we're going to kind of analyze what it means to be an isotope. So if we look, our yellow positive particles in the center where our nucleus is, those are our protons. And if we notice, there are 6 protons in every single one. And we can see that they all also have 6 electrons. This is because they're overall neutral atoms. But when we look at our ion or our neutrons, okay, the first atom of carbon has 6 neutrons, the second one in the middle has 7, and the one on the right side has 8. And so we can see that their neutrons are changing each time, and we see so does this number here, okay? And that number is our mass number, because remember, our mass is our protons plus our neutrons. Okay, it's always our protons plus our neutrons. So when we look at what's similar, we see that our number of protons and neutrons are the same, or excuse me, not neutrons, our electrons are the same, but our number of neutrons is different, okay? And this is what makes something an isotope. So these pictures represent isotopes of carbon, okay? And so 2 atoms are isotopes if they have the same number of protons but have different neutrons, okay? And so isotopes have different atomic masses because of the change in those neutrons, because if you change the neutrons, you change the mass. And so the number of protons in an atom is known as the atomic number. That's a review from our previous lesson. And remember, that atomic number is at the top of your box on the periodic table. And the mass number of an atom is the number of protons plus the number of neutrons that are in the nucleus. So the nucleus basically holds all of the mass. And so with isotopes, okay, there is something called isotope notation. Now my page looks a little bit different than the notes that you have. Somehow they got edited. But so isotope notation looks like this, where you have the name of the element hyphen the mass number. So we see here sulfur hyphen 23 and sulfur hyphen 25. So if we use our periodic table, we can determine the number of protons, neutrons, and electrons that each of these have. Sulfur, if you look at your periodic table, is S. It's number 16 and has an average atomic mass of 32.06. Now, what I would like to point out is that the mass numbers of these particular atoms are different when you compare them to the average mass, okay? And that's because, remember, the number on the periodic table is an average. If I give you an isotope notation number, that means I'm not necessarily talking about the average atom, I'm talking about a very specific one. And so the atomic number, or the number that I'm highlighting in blue at the top of the periodic table, tells us the number of protons that we have. So both sulfur atoms are going to have 16 protons. If they had 17 protons, they would be chlorine, or 15 protons and they would be phosphorus. So because they're both sulfur, they have to have 16 protons. Now, because it does not tell us that it has a positive or negative charge, we assume that it's neutral. Okay, so we're going to assume that these are neutral atoms. And so they have 16 electrons as well. So then we get to our neutrons. Now remember, our neutrons are always our mass number minus our protons. Okay, so if we have 23 minus 16, we get 7 neutrons. And when we have 25 minus 16, we get 9 neutrons. And so we can see this is definitely not the average, but this is what we have so far. And so I want you to do the same thing for chromium 58 and pause the video and then press play when you're ready to check. Okay, so check your answers. Hopefully you got that 58 minus 24 protons is 34 neutrons for chromium 58, and that 63 minus 24 is 39 neutrons for chromium 63. And you should be able to look at this as well. Now for this, I want you to change this from isotope notation to symbolic notation. Okay, and symbolic notation looks like this, where you have your symbol as X, and then A is your mass number, B is your atomic number, and C is your charge. So for example, if I have an atom that has 12 protons and 12 neutrons and 10 electrons. Okay, I could write the symbolic notation. Anything with 12 protons is magnesium, and magnesium has the symbol of Mg. And because it has 12 protons, that tells me my atomic number is 12, so I'd put a 12 in the bottom corner. My mass number is always my protons plus my neutrons, so 12 plus 12 is 24. And then my charge. Remember, your charge is always going to be equal to your protons minus your electrons. So 12 protons minus 10 electrons gives me a positive 2 charge. And that's how you do your symbolic notation, which we haven't gotten into charge too much, and we will when we go to page 2 of these notes on the back. But this is what I want you to do for these atoms here. So for zinc 66, if you find zinc on your periodic table, you'll know that zinc 66, zinc has a symbol of Zn with a capital Z. Its atomic number is 30. Because it says that it's zinc 66, we know that our mass number is 66, and they do not tell us anything about the number of electrons or whether or not there's a charge, so we assume it's neutral and we leave the charge area blank. So go ahead and pause the video and then press play when you're ready to check your answers. Okay, so go ahead and check your answers. And make sure that you got these answers. All of these were neutral atoms, or we assume they were neutral because we were given no information about the number of electrons or having a charge. So in this part of the lesson, we talked about isotopes with their names, how they have different number of neutrons, but they're the same element. And now we're going to get into ions. And unfortunately, there's like some error, so kind of get rid of that or ignore that bottom row there. But when we look at these, what we notice that's the same about each element. Notice their protons and neutrons, they're the same across these. But, okay, so we've got the same protons and neutrons, okay? And when we compare it to the first part of our page, okay, here we've got our electrons are different from our protons, which we haven't really seen before, and we have our charges. So we have different number of neutrons, or excuse me, different number of electrons and a charge. And so an ion is an atom or a group of atoms that has a net positive or negative charge. And so this is where the protons and the electrons are not the same number. It's when they're an ion. And so there are two types of ions. Okay, there is a cation, which a cation is an anion, or excuse me, a cation is an ion with a positive charge. And one way to help you remember it is a cat ion. Cats have paws, so cations are positive. Okay, it's cheesy, but it might help you remember. And so cations are where if you have a neutral atom and it loses one or more electrons, it becomes a cation. So here we have something neutral and it loses one electron and it now only has 10 electrons, and now it's a cation. And we can see here that it has a positive charge. And so for anions, okay, this is our second type. Anions are ions. An anion is an ion with a negative charge, and if a neutral atom gains one or more electrons, it becomes an anion. Because remember, electrons are negative, so if I have extra electrons, I have extra negative charge. And so again, here we have a neutral atom because it has 17 protons and 17 electrons, and then it gains one electron to now have a total of 18, and it is now an anion. So for some hints to remember, whenever you see a positive charge, that means you lost electrons. Think about if you get rid of all the negativity or all the negative people in your life, what you're left with is a positive experience. Just like these atoms, when they get rid of those negative electrons, they remain positive. If you have a negative charge, that means you gained electrons. Okay, so when the charge is all about gaining or losing electrons. So when an electron is removed, the resulting charge is positive, but when an electron is added, the resulting charge is negative. And so on this little practice chart, yours looks a little different than mine, and so you can kind of ignore these on my page. You don't have those, but what we're going to do is we're going to write the isotope notation here on yours, and we'll do the symbolic notation here. And so remember, the symbolic notation looks like this, where you have A, B, C. You've got 3 sections, and it's kind of like a puzzle. We've got these missing pieces. So for example, I see that there are 53 protons here. And if I have 53 protons, that means I have an atomic number of 53. Now notice my protons and my electrons are not the same, which is why I have a negative charge here. And then my neutrons I can figure out by saying 127 minus 53, which will give me a number that I'm going to put in my calculator so I don't mess this up on video, 74 neutrons. So once I know my protons, neutrons, and electrons, I can write my isotope and symbolic notation. So 53 protons, atomic number 53 is iodine, and my mass number is 127, so I do iodine hyphen 127. And for my symbolic notation, I would put 127 at the top and 53 at the bottom. The charge is already there. So go ahead and pause the video and try and complete the rest of them and press play when you're ready to check your answers. Okay, so you can go ahead and check your answers. You might need to pause to really be able to check over them fully. One thing I would like to remind you of is if you're struggling with your charge and your electrons, remember that your charge is always equal to your protons minus your electrons, which is why when your protons and electrons are equal, you have a neutral charge or a charge of 0. If you're trying to figure out your number of electrons, though, it's going to be your protons minus the charge. And just be careful when you have a negative charge, because remember, if you have 35 protons and a -1 charge, when you subtract a -1, subtracting a negative becomes positive and you get 36. So remember, if you have a negative number, you should have more electrons than you do protons. So again, check your work here, and you have additional practice that you'll be able to use to get better at this.